Okay, so this problem is a straightforward problem from first semester calculus, and that is to use differentials to approximate the value of a function if you know the value of a function at a given point and you want to find its value at points close by to the given point. So in this one here, oops, excuse me, let's try not to be moving the cursor so much. We're given that g of 1 is equals minus 4, and the derivative of g of x is the square root of x squared plus 8. We don't know what the formula for g of x is, but we can actually derive the formula, and I actually need to use this exact value of the formula in order to draw the graph. But anyway, they're just asking us to use linear approximation to estimate g at 0.9 and g at 1.1 using the following formula. And since we're given, so here we have it again rewritten. G of 1 is equals minus 4, and the derivative of g is equals square root of x squared plus 8. And then taking second derivative, which is also kind of useful because as we move on into the first semester calculus, we see since the second derivative is positive, means the curve is concave upwards. So meaning, by definition, that the tangent line to the curve at that point lies below the curve. And as I reiterated again, if you're in the second semester calculus, you can use trigonometric substitution in integration, and we can actually solve for the solution. But it's kind of tedious, and also requires integration by parts. So use straightforward using linear approximation. G of x plus delta x is approximately g of x plus delta x times derivative of g of x at x, right? In particular for x equals 1 and delta x equals minus 0.0, then we would have the value of g of 0.9 is approximately minus 4 plus minus 0.1 times derivative of g of x at 1. But the derivative of g of x at x equals 1 is just 3. So it's minus 4.3. Now, the actual value, I took the liberty of solving for that, is actually minus 4.29. So it actually underestimates, right? Because minus 0.43 is less than minus 4.29. And particularly for x equals 1 and delta of x equals 0.1, g of 1.1 is approximately minus 4 plus 0.4 times 3, which is minus 3.7, which is minus 3.9. So again, it kind of underestimate, and that's because if you use the exact formula and we plot the curve, it looks like this. So it's almost like a straight line. And if we zoom in on this region here, where this green dot represents when x is equals 1 and g of 1 is minus 4, then we have the following picture, right? So here's at the point 1, 1, and the tangent line in this direction. And here's at the point 0.9 and g of 0. And you can see the tangent line as we move along from 0.9 to 1 to 1.1, it becomes steeper and steeper. So to answer the second part of this question, the tangent lines are positive slope, become steeper since they steeper, and since they lie below the line, therefore the approximate will underestimate the value of the function. And like I say, by taking the second derivative, which is positive in the neighborhood of 1 g1, the curve is concave upward. And a little bit later on in the first semester calculus, we see the utility of the second derivative in determining whether a curve is concave up or concave down. But concave up means exactly the tangent lines are below the curve. So let's kind of put this one here. And for this one, this point, of course, is this point here. I didn't figure it out. I should have put it in there. So that point is 1.1 and g of 1.1. A linear approximation is normally just taught as an application of derivatives in the first semester calculus. Now, I took the liberty solving for this, and I summarized some of the steps here, so we'll just go over it. You don't need to bother with this anyway, but if you find that since the derivative of g of x is equals that, we multiply across by d of x, integrating. And then we actually have to use a trig substitution, right? And then the final result is if you follow through with this, that is, if you're still with me here, we find that g of x is actually equals to secant of theta times tangent, where is what's the relation between theta and x is given by the original substitution. X is equal to square root of 8 tangent of theta. So theta is equals arctan of x over square root of 8. And so our final formula for the function is g of x is equals to this blah, 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 which is 4 secant of the arctan times the tan of the arctan plus 4 times the natural log. Actually, this we should move this over. Well, anyway, it kind of, I think I made this text so large, but it's actually a natural log bracket here of this plus this close bracket here. So that allows us to evaluate for g of 1, which is minus 4, and g of 0.09 is equals to 0.44, and g of 1.1 is minus 3.6. So we needed that in order to get the graph, but didn't ask us to find the graph. But anyway, I drew the graph here. And so that, in a nutshell, is the presentation.